Now we're live. Give me just 1 second to get this kind of set up. I've had tech issues all morning, starting like 10 minutes late because of it, which is fine. This section I don't think will take the entire time. So 1 second to get this kind of set up. So that's not that big of a deal. You guys are the 7-week college algebra class. Done and save. Okay. So maybe now we should be able to get this class rocking and rolling. Okay, so today we're going to talk about the quadratic inequality. So listen, hold on, I have to talk just a minute. So we're going to go over 3.6, just a few housekeeping things. First off, the final is coming up. Remember, it's December 4th. It'll be on a Friday. I know I've mentioned it before. I'm going to mention it again so we don't forget it. You're going to have to set aside some time on that Friday to take the final. If you cannot, please let me know so I can make accommodations. Not a big deal. Also, I think we just took test 3. I'm kind of, the two classes are getting kind of goofy now where the full semester, you guys in the second 7 week are catching up to the full semester classes getting kind of goofy. But we're on the right path. So yesterday we went over 3.5. If you guys have questions about that, please let me know. My Arby's cup is right there. It's real fancy. But if you have any questions about that, let me know. Today we are going to go over the quadratic inequality, which is not bad. It's not bad. It's just different. What's nice is we get to pull out our markers. We get to color. And I know Riker out there is get ready, Riker, because we got a lot of coloring to do today, and I'm excited about it. So I've got all kinds of different colors. I'm going to get to drawing these things, and that's really how I teach the quadratic inequality. So the quadratic inequality in 3.6, you can teach it 2 main ways. One is an algebraic type way. The other is a more visual graphing type way. I go with graphing because that's really how this book has taught quadratics throughout the semester. If you go back to 3.1, that section was really, kind of graphing focused is a way to think of it. So let's get started. So let me move back to my document camera. Here we go. Okay, so I'm going to actually start by drawing one of these before we actually solve how they are in this section. So let's say we had a nice quadratic. Now remember, quadratics were either smiling or frowning, right? They could cross the x-axis. They could not cross the x-axis. We're going to start with one that does. So let's say that this is our f of x function, okay? And it's going to cross the x-axis at 2 different places. We'll have it cross at, let's say, 1 here, and it's at 4, 1, 2, 3, 4. Let's do 5. 1 and 5. And it does something like this. Okay? And I'll tell you, your book really emphasizes where the x-axis or x-intercepts are, and it calls them the boundary points. So you'll hear me say boundary points too. It's a good way to think of those x-intercepts in this section, okay? It's a good way to think of the x-intercepts in this section as boundary points. So the question is going to say, let's say we've got f of x here. We'll keep it in blue. So here's f of x. Let's say for part A, it's going to say, well, where is f of x greater than 0? Okay? Where's f? This is the inequality part, right? We got a quadratic, and we got an inequality, and we want to know where is f of x, this function, greater than 0. Now, I need you to think, and I'm going to go into really more detail than I will later on for this first example, because I need you to think of what that f of x represents. remember that f of x is just y. So this question is saying, where is y? Now, greater than 0, that's where is y positive. So same exact thing. Where's f of x greater than 0 is really asking, where is y positive? So I'm going to go to this y-axis. And notice all the positive y values occur above the x-axis. So like positive 1, positive 2, positive 3, positive 4. Underneath it, it's going to be -1, -2, -3, and so on, right? So all the positive y values are above the x-axis. So when the question asks, well, where's f of x greater than 0, it's really saying, where is y positive? Now listen, for these inequalities, we're always going to state these with interval notation on the x-axis. It's really saying, where on the x-axis is y positive? So I'm going to take out another color now, and we're going to draw these boundary points. And I'm going to really think of them like boundary points. So look, here's a boundary point. Make a little fence there. And here's a boundary point. Okay? To the left of this boundary point, is that positive 1? Yeah. All of our y values are greater than 0. They're all positive, right? If I put in like -1 here, I get back up positive 5-ish, okay? But then if I chose like 1, 2, if I chose 3 here, x equals 3, I would get a negative y value. So look, all of the values to the left of -1, I'm sorry, positive 1, all the values to the left of positive 1 are going to give me positive y values. And all of the values to the right of, what was this, 1, 2, 3, 4, 5, of 5, give me a positive y value. So I'm gonna kind of draw these. This is x equals 1, right? I know it's kind of hard to see with this marker, this pen. X equals 5. Those are our boundary points. So to the left of 1, we have positive y values, and to the right of 5, we have positive y values. We don't include the middle because all the y values that are underneath here are negative. They're not greater than 0. They're less than 0. Okay? So how would I write this? Now, I'm going to use these red intervals, actually. So -infinity to positive 1. Now, look, I'm not going to include 1 because we're greater than. If there was an equal to, we would use a bracket. Okay? So we're actually, if you want to make it curved, that's fine. So from -infinity, negative infinity is out here, all the way to 1, we have positive y values. Then from 1 to 5, we have negative y values. So we're not going to include them for this example. But then at positive 5 to infinity, so we're going to do union, 5 to infinity, we also have positive y values. So this would be our solution. Okay, we've got -infinity to 1. We're above the y-axis. That's what this means. And then from 5 to infinity, we're above the y-axis. Kind of cool. I know. You don't have to tell me. Okay? I would say questions, but I don't think anyone's here. Okay, so let's do another one, and really let's see how these are going to be written in the homework. And so instead of me giving you a graph, we're going to be given an equation, and we're going to be asked to graph it and then find it. Okay, so this is really how they're going to start. Okay, there we go. Let's say we've got x squared minus x is less than or equal to 6. Okay? X squared minus x is less than or equal to 6. So now, the first thing you've got to do is solve it like you're kind of solving a quadratic equation. I've got to move the 6 over. I need 0 on one side, okay? So I'm moving the 6 over. Get x squared minus x minus 6 is less than or equal to 0, okay? Now look, this is our function now, just like the example before. There's our function, and we're wondering, where is our function less than or equal to 0? So really what we're saying, where are these y values below the x-axis? Okay, where are these y values below the x-axis? So let's look. The first thing we're going to do is we're going to graph this thing. Okay, so step one, actually, I guess step one is get 0 on one side of the equation. Step two is graph this. Now you can use your calculator if you want to graph it. It's nice whenever we have nice whole numbers when we graph the calculator. I'm going to just do a quick run through on how to graph these. This is back from in section 3.1, but I'll tell you the only thing that matters are the x-intercepts. Remember, those are our boundary points, so this is the only thing that's going to matter. I need to find the x-intercepts of this. So I'm going to find the x-intercepts. And to do this, remember you set the whole function equal to 0. And this factors nicely. X minus 3, x plus 2, right? Multiplies to give me -6, adds to give me a -1. So if x minus 3 equals 0, x equals 3 is a 0, or a y-intercept. And x equals -2 is a y-intercept. So that's all I really need. I don't need all the extra points because I know that this thing opens up. It's smiling, right? Because the a is positive. And I know it goes through 2 intercepts. So I'm going to graph what I know right now. So 3 and -2. So I'm going to x, there's 1, 1, 2, 3, 1, 2, 3. Add a few more. Not a big deal. All that matters is where this thing crosses the x-intercept. And we know it crosses at 3, 1, 2, 3. And we know it crosses at -2. Okay? So I'm going to graph this. Now I know it's smiling because this value is 1, right? It's positive. So it does something like this. Okay. It looks something like that. It's not perfect. It doesn't have to be perfect. All that has to be perfect are our boundary points. Okay. That's the only thing that has to be perfect. And our boundary points here are x equals -2 and x equals +3. Okay. And now I've got to go back to this question right here. This is what's important. I need to know where is this graph? Here's our graph. There's the equation. There's the graph. Where is this graph less than or equal to 0? So for this question, I'm going to write this one out too. Where is the graph? I'm going to write it like this. Under the x-axis. It's another way to think of it. Where is this graph under the x-axis? Because it's a less than, okay? Because it's a less than, I want to know where is it under the x-axis. Where are the y values negative? Well, they're negative below this x-axis, okay? They're below down here. So let me draw this thing up. Let's use another color. As many colors as we can today, okay? We're using up all our marker collection. So now if I want to do below the x-axis, I would go from here to here, right? This interval gives us negative y values. Outside of the interval gives me positive y values, right? These are positive y values. But inside the interval, if I plug in like, say x equals 1 is in here, it gives me a negative y value. That means if I plugged in 1 here, it'd give me a number less than or equal to 0. Okay, so this lines up. My interval for this solution is going to be between. Now, look, it's using an equal to, less than, or equal to, so I'm going to use a bracket. So -2 to 3. And we use a bracket because we can equal it. Okay, we use a bracket because we can equal it. Okay. Brian, do you have any questions right now? Any comments, concerns? Okay. Let's see here. Ooh, hold on. Give me just one second. Okay, so that's 2 different types of examples. Let's go over one that maybe is a little harder to factor, so we can just actually we're gonna have to use we can use a look. You can use a calculator and see where this thing crosses the x-axis and be done. It makes our life a lot easier. Okay, let's look at one. Okay, excuse me. I'm gonna steal one from your book. This is number 6 in your book. X squared minus 4x plus 3 is less than 0. So we want to know, where is this function less than 0? Now look, check this out. Where's my calculator? I had to haul it back up here. Oh, there it is. Okay, give me 1 second to get this thing going. Crank it up. Okay. So I'm going to go to y equals, and I'm going to put this into my graph. Okay, so I'm going to clear that out. I'm going to do x, remember x comma t comma theta comma n squared minus 4x plus 3. Okay, and then I'm going to hit graph. Let's see if we can see where these cross the x-axis without actually having to do any real math. We can use the calculator. Yeah, it looks like it crosses at 1 and 3. Okay, now to check that, I'm going to do the table. So I'm going to hit second table. And if you're like, Mr. Shirley, you're going way too slow, this is a recording. You can pause me. Okay, just pause me and then try to find all the buttons. Now notice, x equals 1 has a y value of 0. So definitely we cross at x equals 1. And then the same thing with 3. X equals 3 also has a y value of 0. So that means we did find our two x-intercepts. So without doing any math, we know that this graph, I'll stick to green for the graph, it kind of makes sense. 1, 2, 3, 4. We know that this graph crosses at 1 and 3. So it does something like this. I'm not worried about any other points because these are the boundary points. So 1 and 3. And that gives us, now if you go back to the graph, you hit the graph button. Yeah, looks pretty close. Doesn't have to be perfect. But what matters is we found our boundary points, right? X equals 1 and x equals 3. And so now we have to think, is this question asking for under the x-axis or above the x-axis? And we've got a less than. Now, less than means below the x-axis. So that means it's the interval in between those two boundary points because it's below the x-axis. Okay, now it's less than, so it's not going to include it. So we're going to use parentheses, 1 comma 3, 1 to 3, right? This function is less than 0 from x equals 1 to x equals 3. We're not including 1 and 3 because it's a less than and not a less than or equal to, right? If this was an equal to, we would have used brackets, okay? We would have used brackets. Okay, questions? Wait, questions? Brianna, are you there? I'm not sure if you're there or not. Let me just turn that thing on and then move back to bed. I cannot blame you. I would do the same thing. Okay, let's do another one. Let's change it up a little bit. Let's say I've got, this is like 24. It looks a little different. Negative x squared plus 2x. 24. There's greater than or equal to 0. Okay. Negative x squared minus 2x greater than or equal to 0. I'm gonna find the x-intercepts for this one. You can graph it if you want to check it. Maybe we'll do that too. We'll graph it just to see if we get the same thing. So I'm gonna do like we did before. I'm gonna set this equal to 0. If I want to find the x-intercepts, I've got to factor out the x here. I get negative x plus 2, right? Set each one of those equal to 0. So it looks like x equals 0 is going to be one of my zeros. Negative x plus 2 equals 0. Add the x to the other side. I wind up with x equals 2. So I've got my two boundary points are 0 and 2. But when I graph this one, I have to be careful. It's a negative out front, so it's going to be frowning. That's okay. Quadratic. It does feel like another Monday. 1, 2, boom. Okay, so we know that this thing we'll do Christmas colors. Last night I tried to watch Christmas Vacation for the first time. I usually try to get in at least 4 or 5 viewings of Christmas Vacation before Christmas starts. But I couldn't have fell asleep. I was tired. Okay, so but we got the Christmas colors going on. So we know we cross at 0 and we cross at 2, and it looks something like this. Something like that. It's not perfect. It doesn't have to be perfect. But what matters again is we have our 2 boundary points, right? X equals 0 and x equals 2. Now I got to think. The question now is asking, where is it greater than or equal to 0? Well, that's above the x-axis. So it wants in between here, right? Because these values are above the x-axis, right? These are the positive y values. These are the negatives. So again, it wants in between. Now it's an equal to. So we're going to include the 0 and the 2. So 0 to 2 with brackets. Okay. Questions, comments, concerns? I mean, that's it. This section is a really short section, and I've really done all the examples I can do. For homework, it's on page 420, and it's numbers 1 through 27 odd. Okay, so it's not a long section today. 1 through 27 odd. Try those. I'm going to assume you guys will have more questions from 3.5. And our next lecture tomorrow, we're going to go to 4.1. It's a very short lecture. 4.1 is not a long lecture at all. So I am expecting, here, let me put it back on me for a minute. Yeah, tomorrow's lecture is over 4.1, and 4.1 is really a smaller section before our next test. I'm going to assume there's going to be more questions about section 3.5. 3.5 is not the easiest section. If you watch those videos, you really should have questions. I kind of expect questions because it's not the easiest of all the sections in class. And that's actually why I put it on this test. So you've got 3.5, which is larger. 3.6 is a little smaller. 4.1 is the smallest. 4.1 might be the shortest section we have in college algebra. But I look forward to tomorrow. Today it's just a short lecture. It's not a long topic. If you have any questions, let me know. Email me. We've got a lot going on coming up. I mean, we're really only like 2 weeks away, aren't we? Holy cow. Yeah, but about 2.